Imagine being one of the first humans to set foot on the scorching alien landscape of Venus, our long-lost sister planet. The very thought sends a shiver down the spine. In this edge-of-your-seat adventure, we'll explore the harrowing challenges and cutting-edge technologies that could one day make a Venusian landing not just possible, but downright thrilling. Prepare to be on the edge of your seat as we uncover the high-stakes drama of surviving the most hostile planetary environment in our solar system. Can humans survive Venus? Venus is often called Earth's sister planet due to their similar size and composition. However, its hostile environment makes colonization seem impossible. Extreme heat, acidic clouds, and crushing pressure pose major threats. While robots have explored Venus's shellfish surface, no human has ever set foot there. Is the permanent human habitation of Venus truly beyond our capabilities? With new materials and technologies, some scientists believe habitability could one day be achieved through cloud cities or subterranean settlements. But could landing safely even be possible under present conditions? Preparing for the harsh descent. The most daunting challenge for any prospective Venus mission is, without a doubt, the extreme heat and pressures faced during atmospheric entry. As a spacecraft descends through Venus's dense carbon dioxide atmosphere, it encounters immense friction that generates surface temperatures exceeding 500 degrees Celsius, hot enough to melt lead. Radiation levels also spike sharply. Simply shielding a vessel from these intense thermal and pressure forces requires the development of radically advanced heat-resistant materials not yet achievable with current technology. As if that weren't difficult enough, powerful winds shear upwards of 350 miles per hour and the possibility of ferocious electrical storms endanger traditional parachute descent methods. Wind at these speeds can easily rip parachutes apart before a safe landing is possible. Novel designs for unpowered aircraft or balloons may offer more atmospheric control during the prolonged float down through the thick carbon dioxide-filled clouds. However, constructing and navigating such an aircraft to survive remains a major sub-challenge. Successfully penetrating Venus's atmosphere presents by far the most severe engineering obstacle to any prospect, devising materials and systems sturdy enough to withstand the extreme violence of atmospheric entry may be the primary factor determining whether humanity achieves a first landing there. For the time being, atmospheric descent stands as our prime technological roadblock. Dropping through noxious clouds, Venus's atmosphere presents serious risks, with approximately 90% comprised of highly toxic carbon dioxide gas. Additionally, the dense clouds are concentrated with strongly acidic compounds like sulfuric acid and sulfur dioxide. Simply breathing in these corrosive fumes could inflict severe chemical burning of soft tissues like the lungs. Even structurally reinforced vehicle exteriors may not provide adequate insulation from this caustic cloud layer. Prolonged exposure could result in corrosion and degradation of necessary mechanical components and electronic systems. Making matters worse, the clouds also condense into abnormally large raindrop droplets capable of compromising parachute-based delivery systems. Without developing materials remarkably resistant to this hostile atmospheric chemistry, as well as the larger rain, any concept of flotation through Venus's clouds or powered flight appears virtually impossible while safely transporting human pilots or crews. First and foremost, scientists must focus on creating durable protective surface coatings and linings for all envisioned spacecraft, probes, and prospective habitats to have any hopes of enduring the hellish conditions above Venus's surface. Preparing for extremophile survival. Even if the formidable challenge of withstanding atmospheric entry can be achieved, simply surviving on Venus's surface brings its extreme hazards. Surface temperatures of a scorching 462 degrees Celsius could melt lead, while the immense atmospheric pressure averages a crushing 90 times greater than Earth's, enough force to crush a deep-sea submarine. However, there is a glimmer of hope. Obscure extraterrestrial microbes that thrive in Earth's most unforgiving hot springs and seafloor vents endure comparably hellish conditions without harm. These novel extremophiles hint that engineered habitats applying related adaptive principles may just shield human inhabitants. Nonetheless, developing structural and protective materials that are able to counter such extreme heat and pressure, while also accommodating life-critical functions, poses a towering materials science problem. Shielding humans from surface temperatures capable of melting, our spacesuits pushes technology to its utter limits. Conquering this challenge remains crucial before considering establishing a surface outpost, taming a runaway greenhouse. To envision permanent colonies on Venus, terraforming the environment into more Earth-like and sustainable conditions is imperative. However, altering a planet with a 96.5% carbon dioxide atmosphere contributing to a maximum greenhouse effect presents enormous obstacles. Proposals involve radical approaches like dimming sunlight via orbiting sunshades for centuries or removing atmospheric hydrogen into space. But the realities of such planetary engineering projects far surpass all previous terraforming notions in strategic scale and complexity. Unknown, geopolitical impacts and potential environmental disruptions dwarf prior conjectures. Technologies enabling zero-carbon operations on the scale needed also remain science fiction. Considering the magnitude of challenges, terraforming Venus appears effectively impossible, given our current scientific understanding. More fundamentally, enormous strides must first be made in simply engineering probes, aircraft, and outer shells able to operate under Venus's present extreme temperature and pressure conditions near its surface and atmosphere. Only through continued progress on Earth could outer planet environmental manipulation someday become conceivable. Prospecting aerial colonies. If surface colonization fails, could floating cities endure in more temperate areas of the upper atmosphere? Between altitudes 50-65 km, temperatures stay a balmy 20-40 degrees C, with pressures similar to Earth at sea level. Hydrogen-filled dirigibles shielded by multi-layer insulation could theoretically house sizable populations here. However, acquiring helium-3 fusion fuel and constructing durable structures able to withstand omnipresent winds, lightning, and acids remain enormous stumbling blocks. Life support features like breathable atmospheres introduce further layers of difficulty. Cautious optimism for robotic exploration. Despite the incredibly challenging conditions presented by Venus's hellish environment, scientists remain dedicated to overcoming the obstacles through refined robotic probe designs. Recent conceptual missions propose utilizing cutting-edge aeroshell technologies and advanced heat-resistant materials like aluminized thermoplastics to survive the superheated atmospheric descent better. Subsurface radar systems deployed through fleets of stationary balloons and gliding craft may eventually uncover subsurface pockets that maintain more temperate conditions, while enormous engineering hurdles undoubtedly remain before such ambitious Venus exploration schemes can become reality. Each successive generation of hardened robot missions aids in building core knowledge about potential temperature variations and operational niches within Venus's fringe environments. This critical data collection paves the way for iterative testing of new aerospace technologies, which is ultimately necessary before future consideration of human-crewed missions to our sister world can enter feasibility discussions. Robotic reconnaissance thus becomes the first stepping stone, the ultimate frontier challenge. Colonizing our sister planet Venus will assuredly rank among humanity's greatest technological feats. But as we expand life's frontier across the solar system, even pushing the boundaries of what's possible, its hellish climate tests engineering to its limits. For now, landing people on Venus appears unfeasible. Yet each successful probe sent to scout this enigmatic world illuminates new options that may one day allow brave pioneers to walk among its cloud cities or subsurface caverns. If accomplished, establishing permanent Venusian settlements would undoubtedly solidify our status as a multi-planetary species. However, tremendous scientific progress and innovation have remained the price of entry into another world. Whew, what a wild ride that was, wasn't it? If your heart isn't racing and your palms aren't sweaty after that journey to Venus, then you must have ice in your veins. Now, before you go, don't forget to smash that like button, subscribe to our channel, and share this video with everyone you know.